which is intellectually amusing, is suppose we used to have a telescope up in Haleakala where we were trying to measure some pulsars and the timing of the pulsars. And so that was my only experience with having to really get into the timing equations for the arrival time of the pulsars. So some of these damn pulsars are millisecond pulsars. So you really want to have these buggers timed down to microseconds or nanoseconds even. But to do that, you have to take account of all kinds of things. Well, maybe the first is just the rotation of the Earth around its barycenter, the center of mass of the Earth-Moon system. So I have to put that in with the rotation of the Earth around its own axis, right? So I have to get that straightened out. So I make a correction there of kilometers scale. And then I have to put in a correction for where we are in our orbit around the sun. But it's not just about the sun. So you might think that, I was thinking about it in terms here, we're describing the motion about the Kepler's laws being in terms of the square of the periods of the planets being proportional to the cube of their major axes. But it's not quite so, because the sun is not infinitely massive compared to the planets. And so the center of mass of the sun does move about. And if you look it up on the web, you'll be amazed that yellow thing is the size of the sun. And that's how much the barycenter of the sun moves about. This is just plotting from 1945 to present. Did you have any idea that the center of mass of the solar system moved around that much?
Not that much, but it has to move around.
Yeah, it moves around. I did not recall that it was that large. And so from day to day, the calculations that you put in are moving, aside from the Earth orbital motion, just meters. But this is the diameter of the sun, going out to twice the radius or something like that. And for some time, for some periods in the mid-80s and late 50s, it was a long ways outside of the sun. Where are we now? We're on the way out. And sometime in 1990 it was pretty close to the center of the sun. But it looks like we're on the way out right now.
And then eventually that will create a bigger flower around the...
Yeah, but you can see this is a horrifically messy thing, because this is the combined effect of a bunch of, especially the heavy planets, Saturn, Jupiter and Saturn, who have a long lever arm, and they all have slightly incommensurate orbital periods. But, there will be times, I suppose this must have been a time when they were all pretty much on one side. So it's pretty neat stuff. And if you're interested, you can just look up barycentering on the web, and you'll see that if you're going to do precise timing, you really have to put in all of these corrections. And it's taken some time for people to get it all straight so that we can. It's very important, for instance, right now in the hunting for Earth-like planets, another place where it comes up. Because you're wanting, in this case for the planets, what you're wanting to look at is relative velocities. Because we're talking about measuring a few centimeters per second relative, all of this stuff that's done looking for these. You're looking for tiny line shifts to see motions in planetary systems that are 10, 20, 100 light years out. And they're having more and more success with. But all of that also depends on getting all of this stuff straight. So there's lots of fun in playing with these things, if that floats your boat anyway. If that's your idea of fun.